All right, and here's our wrap-up video. So we were working on these two main translation properties, this one right here and this one right here, just the forward and backward directions. So we started with the translation of e to the at times f leads to translation in the s domain, capital F of s minus a. We did some forward examples and then some inverse examples, and these took some reasoning where we had to kind of make the s minus a term appear in the numerator where it didn't already. And so these examples could be a little tricky. And then we did a differential equation example that actually used that tool. I gave you the overview of that earlier, so I won't talk through the details of it. And then we moved on to the second property, where the kind of shift is in the t domain. We're looking at piecewise functions. And we learned the Laplace transform property, but first we had kind of an aside where we talked about how we even represent a generic piecewise function that somebody might hand to us as something that uses this new step function that we learned the Laplace transform rule in terms of. And then we did some forward examples where writing down what f is, and especially making sure that it copies the f of t minus a, u of t minus a pattern, can be a little bit tricky. But then when we did the inverse examples, they tend to go a bit more quickly because that direction is easier. And so I gave you like a guide for writing piecewise functions using the step function if you want to. So on this page, I've just sort of summarized everything we did. As far as the forward direction goes, if you're taking Laplace of e to the at times f, you just introduce that shift, capital F of s minus a. Not too bad. Whenever you have a piecewise function, you have to use u of t minus a, and that thing's kind of tricky because we have to write f, and then we have to make sure it has that same form, f of t minus a, u of t minus a. For the inverse, whenever you see repeating patterns of s minus a, you know that you have to use e to the at times f, but this direction is kind of tricky because you have to introduce that s minus a everywhere if it only appears in some places. But if you have e to the minus as times capital F, you just know that you have to go back to a piecewise function. And so the backward direction using that second property isn't too bad. Your practice problem is to compute the Laplace transform without using integrals. So I know that you can use integrals to compute the Laplace transform of the piecewise function. I want you to use this new tool that we learned for this lecture, where your f is 0 below 2 and then t after 2. So go ahead and work on that problem, and I will see you in class.